Hello, good evening. We are here to continue the chapter on network in graph theory. All right. So we move on to the next part. Okay. So just a recap on what is a graph. All right. Okay. A graph is usually used to represent a network. All right. A network is a part of a graph with the vertices and edges having their own characteristics. So the structure of a network is a many-to-many relation. Okay, so a graph can be denoted by a set of ordered pairs, and this is the abbreviation for a graph. G braces V. V stands for vertices, and E stands for edges. So in any graph, so V is actually a set of all the vertices V1 right up to Vn. And E stands for your edges, E1 right up to En. Now E can be written in this based on the graph given to you, or it can also be written in ordered pairs like this, whereby A and B are actually vertices. Alright, okay, so from graph we move on to something known as a subgraph. Okay, what is a subgraph? Okay, now a subgraph, the word sub itself means a part of. Okay, so a subgraph is actually a part of the entire whole graph without changing the original position of the vertices and the edges. Now this is important, without changing the position of the edges and vertices. Now if H represents a subgraph and G is the graph, okay, now these are the conditions that will apply. The vertices, this is B, vertices for your subgraph is actually a subset of vertices in the actual graph. Okay, meaning, okay, let's say in your actual graph you have about 10 vertices. So maybe a subgraph only represents 5 vertices. So 5 is actually a part of a portion of the value of 10. So VH is actually a subset of VG. Okay, second condition is the edges in a subgraph is also a subset of the edges in the original graph. Okay, and the lastly, the vertex point of edges of H are the same as the edges of G. It means in this case, the edges in the subgraph and the edges in the G, the original, does not change. All right. Okay, so we take this as an example. Let's say as an example, you have got 4 vertices, P, Q, R, and S. Okay, these are your E, these are your edges. So E1, E2. Now E2 is a loop. This is a loop at vertex G, at vertex Q, E3, E4, and E5. So that means all in there are 1, 2, 3, 4 vertices. 1, 2, 3, 4, 5 edges. All right, that makes up this graph. So this is actually a graph. This is the graph G. Okay, so now we want to know whether which are actually subgraphs and which are not. Okay, so we take the first one here. First one, it is, what is drawn is PS. It means this part of it is drawn, and this is E5. So now they want you to check whether this is a subgraph. Okay, you check this with the original. This is true, this is true, this is correct. So this becomes a subgraph of this original graph. Okay, all right, next one is you got vertex P, Q, and this is S. Okay, so we check. This is E5, okay, correct. This is S, correct. This is Q, correct. Okay, and this is P. Okay, now if you check the edges, E1, correct, but this E2 is wrongly drawn. E2 is supposed to be here, not here. Okay, so therefore, just because of this thing here, this is not a subgraph because of this property. Okay, so this is not. All right. Okay, third one is this. P to S, P, S. This is written as E3. In the actual graph, it's E5. So this is wrong. Okay, this is Q, vertex Q, and there is a loop here, and that's E2. Okay, this is correct. So in this case, this is wrong, so therefore this is not a subgraph. Okay, next one is the fourth one. You've got P, Q, R, and S. Okay, this is all correct for vertices. Okay, we go for, this is E3. See, the original graph is actually E2. This is E3, so this is wrong. Here, this is also wrong. Supposed to be E3 is written as E2. This is correct. This is correct. This is correct. But because of these two properties, this is also not a subgraph. Okay? All right? Okay. So that is a subgraph. Okay, now, what is a tree? A tree? A tree of a graph is a subgraph of a graph. That means it's actually almost similar to what we saw just now. Okay, it's a simple graph without loops and multiple edges. It has got no loops and it's got no multiple edges. Okay, so all vertices are connected and each pair is connected by only one edge. So meaning, just now we saw a subgraph. A subgraph can actually have loops and multiple edges, but when you talk about a tree, we got no loops, we've got no multiple edges. All right, and each vertex is actually only connected by one edge. Okay, so, and the third one is the number of edges in your tree will be the number of vertices minus 1. So meaning if the number of vertices is n, so it's n minus 1 edges. Okay, all right, we take a simple example. Let's say I've got 1, 2, 3, 4, 5. I've got 5 vertices. Now, the question is this a tree? All right, so let's check. All vertices are connected. There is no isolated vertex. All right, okay, they're all connected. So every pair of vertices, every pair of vertices is connected by one edge. That means one here, one here, one here, one here. So this is okay. And there's no loops or no and multiple edges. No loops, no multiple edges. Okay. And you've got 1, 2, 3, 4, 5 edges. 5 vertices, and you've got 1, 2, 3, 4 edges. All right. So therefore, this is a tree. Okay, let's check the second example. Let's say this one. I've got A, B, C, D, and E. Now, this doesn't look like a tree. Why? Because when we look at B and E, according to the condition, every pair of vertex is actually only connected by one edge. But here we notice vertex B and E have two edges, means one here for B, one here, one here. So C, BE and BC. Likewise for E, I've got BE and BD. So that's one. Number two is these are all, you only have 5 vertices. So 5 vertices must only have 4 edges because according to the formula is n minus 1. So here I've got 1, 2, 3, 4, 5. So therefore this is not a tree. Okay. Okay, so move on to the next part. It's a simple example. Okay, now the question is, draw a tree with 6 vertices. Okay, 6 vertices means a tree. It's just trial and error. That means if you have 6 vertices means I should only have 5 edges, because the formula is n minus 1. So this is 6 minus 1, so I only have 5 edges. So maybe 1, 2, 3, 4, 5, 6. So probably I can do this 1, 2, 3, 4, 5. Okay, so that will be a tree. Okay, 8 vertices. 8 vertices means I must only have 7 edges. Alright, okay, so 8 vertices, maybe we start here 1, 2, 3, okay, 4, 5, 6, 7, 8. Okay, maybe. So 1, 2, 3, 4, 5, 6, 7. Okay, so that will become, that's a tree lah. Okay, it looks like a family tree. Normally a family tree will have something like this. Okay, next I've got 4 edges, means I must have 5 vertices. Alright. Okay, 4 edges, 5 vertices. So probably okay, let's try. This is trial and error. Maybe 1, 2, 3, 4. Okay, 4 edges. 1, 2, 3, and 4. Alright. Okay, and the last one, 9. 9 edges. Okay, this one you try it out. See, the shape does not matter. What matters now is if you have 9 edges, meaning you must have 10 vertices. How you place the vertices depends on you, so long as you abide by the rule that you must have only 9 edges. Okay, so this is a simple example of a tree. Alright. Okay, lastly, the question says, okay, we want to draw a tree. Okay, if you notice, is this a tree? 1, 2, 3, 4, 5. I've got 5 vertices. And how many edges? 1, 2, 3, 4, 5, 6, 7 edges. So this doesn't look like a tree, Alright. So what I can do now is I've only got 5 vertices, so maybe I place it. Maybe let's say we use the same one here, one here. Okay, let's try. 1, 2, 3, 4. So I've got 1, 2, 3, and 4. 4 edges. Okay, alright. Likewise here, a tree. Now this is not a tree. So I've got 1, 2, 1, 2, 3, 4, 5, 6. I've got 6 vertices. So meaning I should only have about 5 edges. Okay, so 1, 2, 3, 4, 5, 6. Okay, I put it back in the actual position and then see whether I can actually get 5 edges. Okay, maybe 1 here, 2, okay, 3, 4, and 5. Okay, so this becomes a tree. Alright. Okay, so these are 2 simple examples. Okay, so what you can do is, based on whatever is taught here, This is your work. Can you please try this? Self-practice 5.1c. This is on page 142. All right. Can you just try question number 1 up to question number 5? All right. So I'll continue the next lesson with something, a little bit something else. So please try to complete this first. Thank you.